Welcome to the session on AWS Lambda. Today we'll be talking about what AWS Lambda is, how it works, and why it's useful. By the end, you'll have a good understanding of how Lambda fits into the AWS ecosystem, and we'll also do a hands-on lab to put what we've learned into practice. Before we dive into Lambda, let's first understand serverless computing. Serverless doesn't mean there are no servers. It just means AWS manages the servers for you. You don't have to worry about setting up, maintaining, or scaling them. Instead, you can focus on writing code and AWS takes care of running it. You don't need to worry about purchasing, configuring, or maintaining physical or virtual servers. Lambda functions are triggered by events from other AWS services, like an API request, a file upload, or a database change. So why should you use Lambda? AWS automatically manages the infrastructure, so you don't have to. This saves time and effort. You only pay when your code is running. If your function runs for 1 second, you pay just for that second. Lambda scales automatically. If you suddenly get more requests, AWS will run multiple instances of your function without you needing to do anything. Now that we know what AWS Lambda is, let's take a look at how it actually works. AWS Lambda doesn't run all the time. It runs only when something triggers it, like a user making an API request or uploading a file to S3. When triggered, AWS automatically provides the resources needed and runs your code. Once your function completes, AWS shuts down the resources so you're not charged for idle time. AWS Lambda supports multiple programming languages, so you can choose the one you're most comfortable with. Python, a popular language for automation and data processing. Node.js, great for building APIs and event-driven applications. Java, which is useful for enterprise applications. Go, known for performance and efficiency. Ruby, often used for web applications. And C#, which is good for .NET developers building cloud applications. AWS Lambda is often used to process API requests when combined with API Gateway. For example, when a user requests data from a website, Lambda can fetch it from a database and return it. You can schedule Lambda functions to run at specific times, like taking database backups every night. If a file is uploaded to S3, Lambda can automatically process it, like resizing images or extracting text from PDFs. Lambda can process real-time data streams, such as analyzing stock prices from Kinesis or updating records in DynamoDB. Lambda pricing is simple and based on usage. Your first 1 million requests per month are free, after which you will pay per request and the time it takes to execute. The first 400,000 gigabyte seconds of compute time per month are free. If you are wanting to provision concurrency, there will be a fee attached. You will not be charged when Lambda is not executing. You can request increases to concurrency, execution time, and memory, but you need to be aware that there will be costs associated with these. AWS Lambda functions have basic performance limits, including a maximum execution time of 15 minutes, a memory limit of 10,240 megabytes, and a default concurrency limit of 1,000 concurrent executions across all functions in a region. Key points to remember when planning on implementing Lambdas. If a Lambda function hasn't run for a while, it takes longer to start. You can keep it warm by invoking it at regular intervals. If your function runs longer than 15 minutes, it will be automatically stopped. For long-running tasks, consider breaking them into smaller functions. Always assign only the necessary permissions to Lambda functions to reduce security risks. Before we jump into the hands-on lab, let's quickly summarize what we've covered about AWS Lambda. We've seen how it can run code in response to events, how it eliminates infrastructure management, and how it integrates with various AWS services. Let's go over these key points one more time before we try it out ourselves. It runs code automatically in response to events. You don't need to manage the infrastructure, and you only pay for what you use. You can use Python, Java, Node.js, and more. and it also works with API Gateway, S3, DynamoDB, and many other AWS services. Many small applications can run completely free. Now let's move on to our hands-on lab and see Lambda in action. This is the architecture of our hands-on lab. We will be creating a Lambda that is triggered when a file is uploaded to a specific S3 bucket. The Lambda will then add a watermark to the image and save the new image to another S3 bucket that the user can access. First, the client uploads the image to an S3 bucket. This triggers the Lambda function. The Lambda function then processes the image, and here we add the watermark to the image. Processed images are saved into another S3 bucket. The modified image is stored separately for easy access. The user can now access the processed image from the S3 bucket. Hi all, and welcome to the hands-on portion of the AWS Introduction to Lambda. Here we're going to be creating the application where we upload an image to an S3 bucket. It automatically triggers a Lambda function that adds a watermark to the image and saves that to another S3 bucket. First thing we're going to be doing is creating the S3 bucket that we're going to be using. We're going to use the general purpose buckets, and we can call this bucket whatever we like. I have got a set of notes that I've worked off of that I'll paste into the description, and I'm just using the name Lambda image watermark for the bucket. We're going to use the defaults for everything and click create bucket. Once we have the bucket, we're going to go in it, and we're going to create two folders. The folders we're going to create are going to be input and output, also just using the defaults. Here we have our two directories in our bucket. The next part, we're going to need to create the IAM role that's going to perform the function, and that will need the permission to the buckets. So we're going to go to roles in IAM roles, and we're going to create a new role. We can base it off of an AWS service and say S3. And then we can search for some more permissions that we're going to add. Let's make sure that it has S3 full access, AWS Lambda basic execution role, and CloudWatch logs full access, so that the Lambda function can create logs for us to monitor if needed. The name that I'm using for the role will be Lambda S3 watermark role. And the trust policy we're going to edit, and we're actually going to change that to Lambda. Should be able to go next again. Lambda SD watermark role. The trust policy is for Lambda, so Lambda can use this role. It has the S3 full access, Lambda basic execution role, and the CloudWatch logs full access. We can click next and create role. We now have our role. We can see it has the permissions inside it over here, and the trust relationship for Lambda to execute it and assume it over here. So this looks good. The next portion, we are going to create the Lambda. The Lambda we're going to be creating from Cloud Shell. The reason we're doing that is we need to build Pillow into it and that we can't do without building outside of the actual function. So here we can also do copy paste. We're going to do a make directory for Lambda watermark, cd into it, and initially I did try and build it with pip outside of using a Docker container, but I think the image that Cloud Shell is running off of as a service is not suited for it. So we're going to be doing it from a Docker container so that it's coming off of a AWS image that is built for Python 3.11 that we'll be using for our Lambda function. So all this is doing is running a Docker container, and it's using a Lambda Python 3.11 and building Pillow for us. And then it's going to output it into our Cloud Shell so that we can use it for creating our function. This will be our function, and we're just going to cat it into a file called lambdafunction.py. I find that's the easiest way so that we have the tab in that isn't affected. This says that it's done. Let's have a look. And we have all our Pillow libraries built here. So that's perfect. Next thing we're going to do is we're going to cat the file so that we have the function itself over here, and we can confirm by just for minutes to have a look at the Python file. So we can see that we're importing Boto3 and we're using Pillow from the libraries that we built previously using the Docker container. It's going to take the image that we pass it, it's going to add a watermark to it, and it's going to save it to an output folder. So it's going to replace the input that it is coming from and being triggered, and it's going to save it to our output folder. This looks good. Now we just have to zip it all, and then we can create the function. We're going to use the CLI for this. The function name we're going to use in Lambda is going to be S3 image watermark. The runtime we're going to use is Python 3.11, the same runtime that we built Pillow with. The role that we're going to use, we need to go and get the IAM ARN. So if we go back to the IAM console, we go to roles, our Lambda S3 watermark, and we copy the ARN for it. We'll be replacing this portion with that. We set in the timeout, the memory size, and the zip file that we'll be building the Lambda function from, which is what we've just zipped up. We can see that it's come back to the terminal and it's ready for us. So that looks to have been successful. Let's open up Lambda so that we can confirm. And here's our S3 image watermark function. We can scroll down and we can see the Pillow libraries that have been imported, and we can see our function. So this looks good. Another thing we're going to do is add a trigger to it. So we want this to be triggered when an image is uploaded to our S3 bucket. The bucket is the Lambda image watermark bucket. The event types that we want, we can just put prefix will be the directory. So it is the input directory that we want it to be triggered from. And the suffix, we want all images to be processed, so I'm not going to set anything here. We acknowledge the warning and add. Here we can see S3 has become a trigger for our Lambda function. And if we open up S3 and we go to our Lambda image watermark bucket and we go to the properties, we can see here that there is an event trigger. When an image is put into the input folder, it is going to call the Lambda function S3 image watermark. So this looks correct. Now we're going to test it. So if we come to our buckets, our Lambda image watermark, our input folder, I have an image here. It's just the AWS logo, no watermark on it. And we will upload this image. That's been successfully uploaded. If we want to confirm that our Lambda function was triggered, we can come back to Lambda, go to Monitor, and we can view the CloudWatch logs. The role that we gave it, that it's going to be using, did have permission to create CloudWatch logs, so we should have them here. And here we can see the logs for the Lambda that ran. This is the start, and here is the end. I don't see any errors. So if we go to our S3, we go back to the bucket and we go to output, we should have another image and this should have the watermark on it. Let's open it up and have a look. And here is our watermark, AWS byte by byte. This was defined in our Lambda function in the code. If you scroll down, over here is the watermark text that we are adding. So we know that this is working as expected. Now in order to clean up afterwards, we can go back to Lambda functions, delete our function, that's been removed. We can go to CloudWatch logs, we can go to the log groups. This is the log group for our Lambda function, and we can delete this as well. It's always a good idea just to clean up afterwards, especially if you're trying to stay within the free tier and not get any unexpected costs. If we go to roles, select the role that we created, the Lambda S3 watermark role, and delete. All that's left now is our bucket. First, we would have to empty the bucket. We know that we don't want anything in it, so we can put in permanently delete. And then we can delete the bucket. Now we've cleaned up everything for this hands-on lab. Thank you very much.